Hello. First of all, we'd like to thank Professor Macaranas of the Asian Institute of Management for the invitation for us to share with you some of our experiences in education, which has been found to deliver optimized learning even before the pandemic and has been shown effective during the pandemic, and we believe even way beyond the pandemic.
Magandang hapon po sa kanilang lahat.
So we'll start with some of the perceived during a pandemic, there's a closure of universities and colleges, which inevitably leads to a no face-to-face interaction between professors and students. And there are perceived disadvantages to this. Like, for example, there would be no classroom lectures and discussions, which people believe would hinder student learning. Most of the time, they would have online and asynchronous learning, which makes it difficult to track inattentive and unengaged students and often leaves behind those which do not have internet connectivity. And the perceived problem is becomes more serious when there is that question about the fidelity of the exams and assessing the learning gains of the students. And there's also the perception that there is a difficulty, especially when handling advanced topics. And the past year also showed that some teachers are resistant against the training of ICT needed for distance learning. And of course, there's also a concern about the laboratory and field skills, which might not be developed in times of lockdown, for example. However, we think that the no face-to-face interaction constraint can be turned into an advantage through a process-induced learning instead of teacher-induced learning, which we have in the CVIF-DLP or Dynamic Learning Program. In the program, it compels students to be independent learners, which is best for training them for the fourth industrial revolution. And it's very easy to mine and make use of results from neurosciences in this program. The program could bypass the ongoing worldwide lack of mature science, technology, and engineering math teachers or STEM. And it's easy to bypass the lack of gadgets or even the lack of connectivity or stable internet connections in this CVIF DLP. And lastly, it would enable our country to catch up with richer countries in terms of education, performance in education. So this CVIF Dynamic Learning Program, which has been shown to be robust against disruptions in education in many occasions, which started in 2002, it is a systems approach to process-induced learning. It incorporates 21st century skills like critical thinking, problem solving, collaboration, and communication skills. And this has been applied from the elementary up to secondary, up to college or tertiary levels. So what is this process-induced learning? Maybe we could ask Vic here.
Yes. Here on this part of the screen, we look at the conventional method. Now, this has been practiced before the pandemic, or we could call that normal times. This has historically been the more accepted method where you have teacher-induced learning. We say teacher-induced because the teacher or the professor plays a very dominant role, whether in lectures, giving lectures, or leading classroom discussions. So here, then you have the students who would be dependent on the professor. So it's common to hear, for example, that students would complain that they do not like mathematics or chemistry or physics because their professor is a terror, or he's not good, or she's not encouraging enough for the students. That is because in this type of approach, you would have, again, personality dependent instruction or education. And now the problem here is you have undocumented transmission of information. The professor might be lecturing or leading discussions. The students might seem to be understanding the lesson, but actually understanding once they are assessed, primarily with exams or a few problem sets, then the scores might tell us a completely different story. So you have here the quality control of the learning gains might be difficult. And this is why in the CVIF in our school, because of this constraint, and it is in a rural area, it was at that time a fourth class municipality, then because of the constraints that we encountered, we had to devise something new, and we call it the dynamic learning program. And in contrast to teacher-induced learning, we have process-induced learning. And what does this mean? The professor is not, or the teacher does not really lecture a lot. In fact, lectures and classroom discussions only occupy 10 to 15% of the time. The focus now would be the learning activity sheets, and this will be explained later. And this would be accomplished by the students daily. Why do we want them to do this daily? Because this gives us high density documentation so that we can gauge or assess the quality and the progress of learning of the students. And of course, because teachers or professors now do not spend a lot of time in classroom lectures and discussions, the students are doing most of the time independent learning, and the daily accomplishment of the learning activity sheets give the professors much data for assessment and progress learning, monitoring of the progress of learning. So to Chris again.
Yes, to give you more details about the dynamic learning program, there are 4 non-negotiable components of the DLP which have been using up to even during the pandemic. The first one is the parallel learning homes, which is automatic during these times. The second component is the activity-based learning activity sheets, learning by doing, where the students do a lot of writing, and there's no introductory lecture before any new topic is being introduced. The third component is an in-house comprehensive portfolio, and the fourth would be strategic rest, which really means nothing beyond the LAS. So let's talk about these 4 components, starting with parallel learning homes. So we could imagine that during the pandemic, we have all these students in their own homes, and they will be doing the learning activity sheets without any teacher intervention, because that's the very design of the LAS, learning activity sheets. There's no need for tutoring, but once a week, they will be assessed. They will have to submit the activities that they have accomplished, and this will be evaluated by the professor and will be part of the grades of the students. So what is the basic design of this learning activity sheets? It's just 1 page. It has to fit 1 page, font 14, so that it will not occupy too much material. It starts with an activity title with 1 to 2 learning targets. This has been implemented since 2002. A short concept digest of the topic that has to be introduced, followed by an example illustration, and it ends with 1 to 3 questions, and everything from the title all the way to the questions should be aligned. Now, this 1-page learning activity sheets, it is actually a series of activity sheets. It is based on the philosophy that any complex task when divided into much smaller steps, becomes manageable even for the challenged learner. The step-by-step series of learning activities build up toward a more elaborate concept, whatever required competency that you want. So what is this learning activity sheet? Maybe we could look at an example. Here's an example. Normally, this would fit into 1 page, but for the PowerPoint, it will occupy 2 pages. So the activity title would be a geometric interpretation of the integral. The learning target is to interpret an integral as the limit of a sum of areas. So it begins with, and the students will have to copy this. In high school, we learn how to calculate the area of plane, figures, and so on. And how do we find the areas for objects with irregular shapes? Now, there are three examples. The first one is given a regular polygon, which is shown on the right-hand side. We obtain its area by dividing that space into triangles. In this case, there would be 6 triangles, and everybody knows how to calculate the area of a triangle. So area of a triangle times 6, and you get the area of this polygon. Example 2, more complicated a little bit, would be area of a polygon formed under the linear function x, as shown in the figure. And again, we make use of familiar geometrical objects. And the blue area we divide into 2 familiar objects, the rectangle and the triangle. And once you get the area easily of a rectangle and a triangle, then that would give you the area of the object on the left. The third example, and this is where we need the calculus, you're asked to get the area under the curve, this under the red curve. So what you do is, this is where calculus is necessary, and we first approximate the area by dividing the region into several rectangles of heights m1, m2, m3, and widths delta x1 up to 3. Then we add the areas of the 3 rectangles. So we have the area of the height times width of the first rectangle plus the second rectangle plus the third rectangle. And this may be written as a summation, as a sum of the area of the 3 rectangles, and that would give you an approximate area of the area under the red curve. And then we end with the question, how can we improve our approximation for the area under the red curve? And for those who are familiar with calculus, you really increase the number of rectangles from 100 to 1,000 to infinite, and then you get the exact area, and the summation sign becomes an integral.
Yes, I would just like to emphasize that the students accomplish this learning activity without any prior discussion by the teacher. So they simply copy and draw the diagrams and try to answer the question on their own without any intervention from the professor.
So in the CVIF-DLP, an ideal learning activity is an activity where 0 teacher intervention is needed. That's why it's immune to lockdowns. And in fact, there's a rule. There should be no introductory lecture. It's not allowed for each learning activity, so that the student will develop critical thinking, problem solving, comprehension, and all these skills needed for the 21st century and for the 4th industrial revolution. Now, there's a protocol in the CVIF-DLP which has been practiced since 2002. And it's stated here, the learning secret, it's not anymore a secret, but don't take notes with a laptop. There are many studies which show that students who used longhand remembered more and had a deeper understanding of the material. So that's why the learning activities should be copied by hand by each student. So writing by hand. In a paper published in Psychological Science by Müller and Oppenheimer, they claim that note-taking with a pen rather than a laptop gives students a better grasp of the subject. And in fact, this study focused on college students, 300 students from Princeton and the University of California, Los Angeles. The Müller and Oppenheimer study demonstrates that students who write out their notes on paper actually learn more. In each study, those who wrote out their notes by hand had a stronger conceptual understanding and were more successful in applying and integrating the material than those who took notes with their laptops. So, in the CVIF-DLP, writing the activities activates both the psychomotor and visual faculties of the brain, as has been observed a long time ago by Professor Hebb, that neurons that fire together are wired together, and neurons that fire out of sync lose their link. And when it comes to experiments, especially during the pandemic, we would like to mention that Albert Einstein and Niels Bohr used a lot of this so-called Gedanken experiment which is a German word for thought experiment, and they were able to discover a lot of laws in nature. And also, you can devise of simple experiments or like the pendulum, which could touch on many areas, like for the simple pendulum, which could be a shoe tied to a string, which everybody has at home. You can talk about acceleration due to gravity, force diagrams, conservation of energy, simple harmonic oscillator, circular functions, waves which are very deep and in physics, given a very simple object. Remember that nature is economical in principle but not in structures. And if necessary, simple and cheap physical demo for deep insights can complement the LAS. There are a lot also of short video clips in the internet. And all the learning activity sheets that they have accomplished, the students will compile in a portfolio. It teaches them organization, another skill important for the fourth industrial revolution. The portfolios can be color-coded, like English for math, yellow for science, and so on. This is just a performance indicator. There are many performance indicators, but in our school, these are the number of UPCAT passers that we have. We had 27 last year, and remember that our school has liberal admission and it follows a standard DepEd curriculum. It's not a science high school. It's located and presently in a third-class municipality. These are some of our graduates. Ronald Joren, who is now doing his PhD at the ETH Zurich. This ETH Zurich is ranked #1 in his area in the world. Another one is our alumna, Madeline Naiga. She's now doing her PhD in Max Planck Institute, which is a very competitive institute. And another example would be Jesha Casañas, who got her BS in anthropology from the University of California, Berkeley. There are a lot of examples, but we just mentioned these three. So in the CVIF-DLP, especially in the pandemic, your problem boils down to the distribution of these bite-sized learning activities. The frequency depends on the state universities and colleges, preferably weekly, so that there would be a routine. It could be bi-weekly at most. And these learning activities would provide optimized learning for the students. They have to write by hand to take advantage of scientific research. And with these learning activities, you can easily assess the learning gains. With the weekly assessment of weekly activities, there's a weekly feedback going back to the subject professor. So in a pandemic scenario, the weekly distribution and collection can be done online if the student is connected, or it could be printed at certain drop-off points, designated drop-off points. And the CVIF-DLP also allows the students to communicate with each other, to develop this skill of collaboration and communication, another valued skill for the fourth industrial revolution. So in the pandemic scenario, contrasting again the conventional and CVIF-DLP, we distribute learning activity sheets, and there's no introductory lecture, 0 to minimal teacher intervention. Tutors are not needed, and there is a weekly assessment to have this routine. On the other hand, the conventional method often encounters difficulty, starting with the teachers who refuse to be trained in distance learning. And the modules that are distributed, there are thousands of modules out there, but there are modules designed for lectures, and then without connectivity, this becomes difficult. So some questions. During a pandemic, what is the guarantee that each student is learning? Well, in the CVIF-DLP, the LAS is copied by hand and answered in the student's own handwriting, which involves the psychomotor, visual, and when read aloud, the hearing faculties of the brain. Another question would be, with the CVIF-DLP as distance learning, how are learning outcomes assessed outside of the test? The learning outcomes are assessed through these learning activities that the students will have to accomplish day by day in their own handwriting. That's the guarantee. In the other distance learning, it's copy and paste, and it's hard to to check whether the student really did it or not. So the CVIF-Dynamic Learning Program, it addresses the learner disposition. It's habit forming daily protocol where students are engaged. And it addresses the absence of teachers. The bite-sized learning activities are done independently 80 to 100% of the time. It bypasses limited face-to-face learning and inexpensive internet connectivity. So if you are a group of universities, you can form yourselves into clusters or consortia. So we have here a diagram of several universities cooperating, and the important point here is a learning LAS hub. So for example, in University 1, they have a very good chemistry teacher. They could contribute their LAS to the hub, and the other universities can benefit from that LAS. In one university, they might be good in agriculture, and they could contribute this to the hub, and everybody could share this LAS given this LAS made by an agricultural school. And this has been actually done before nationwide when we did our Learning Physics as One Nation, where we had 239 LAS and 18 DVDs distributed nationwide, and this was actually assessed post-test and pre-test, and it was a successful in 2008. Within a university, suppose this is one main campus of a university, then those LAS made activities can be distributed to several campuses via email, and once it goes to one campus, then each campus can now distribute that either online or printed copies to barangay halls or drop-off stations or LGU. So this is one setup of how you can distribute the LAS, and this could be distributed and retrieved weekly or collected weekly.
So, well, the outstanding questions during a pandemic, as we have mentioned before, the DLP, we thought of the DLP because of the constraints of poverty and, well, the remoteness of the town that we were working in. But as it turned out, during a pandemic, the constraints are simulated, and therefore the DLP still works. For example, can students learn well when there is a lockdown advisory or shelter in place to slow down the spread of infection? And we say yes, they can achieve, it is possible to achieve high learning outcomes. Can superior learning outcomes still be achieved? Yes. Is it necessary for professors to guide students in their lessons? Basically, no. As long as the learning activity sheets are well designed, then intervention becomes optional. How about for advanced topics? Yes. I mean, professors' interventions may not even be necessary as long as the activity sheets are well designed. Both Chris and I have taught in college and also in graduate school before we got involved in high school, so we have some idea of how this can be done. Can we bypass the worldwide lack of mature STEM teachers in basic education? And we say yes, as well as in tertiary education. By the way, when we say mature, why do we say mature? That is because when professors or instructors are still immature, everything is important. But a mature professor can actually pick out highlights of any topic and discuss them or compose an LAS in such a way that it is very simple. Are we taking advantage of new results from the neurosciences? Yes. Is there a low-cost educational program that would allow poorer nations to catch up with advanced countries with higher educational budgets? And our thesis is yes. So this can all be done even during the pandemic and beyond the pandemic if we want to catch up. Thank you.